Let's continue with section 5.4, complex rational expressions. So complex rational expressions can look very intimidating, but you have all the tools to work with these problems. A complex rational expression is a rational expression that contains rational expressions within its numerator and denominator. So notice we have a fraction and a fraction, creating a bigger fraction. So the way I best recommend you go about it is by approaching it using a process you already know. Okay, my best advice is to rewrite it. So we know this is a division, so let's rewrite it to be 1 plus 1 over x divided by 1 minus 1 over x squared. Okay, then from there, treat it like an order of operations problem. So I want to clean this up. I need to multiply by x over x so that I can get a common denominator. So I have x over x plus 1 over x. That gives me x plus 1 over x. On the other side, we multiply by an x squared over x squared to get a common denominator. We're left with x squared over x squared minus 1 over x squared. We're left with x squared minus 1 divided by x squared. Let's go back to this division problem. Okay, how do we divide fractions? We keep, change, and flip so that we have x. No, we keep the first one. So x plus 1 divided by x times, we flip the second, x squared divided by x squared minus 1. And then we go ahead and multiply across. So we have x plus 1 times x squared. At the bottom I have x times x squared minus 1. And we see that this can be factored. It's a differences of squares. So that we have x plus 1 times x squared divided by x times x plus 1, x minus 1. So here we see our x plus 1 or x plus 1 divide to make 1 or cancel. So that we're left with x squared divided by x times x minus 1. So what we did here is we used a process we're familiar with and just attacked it using what we know. Now, another way to do this is to find your greatest common denominator, often called your greatest common denominator. So you look at all of your denominators and you create a monster common denominator. So for this first one, I have a 5 and a 1, and for our denominator, we have a 1 and a 3. Our problem is asking to simplify 1 over 5 plus x divided by x minus 1 over 3. So what we're going to do is we're going to think of all the denominators. So our greatest common denominator, we have a 5, a 1, and a 3. So we're going to multiply by 5 times 3 to every single term. So this is going to be multiplied by 5 times 3. This is going to be multiplied by 5 times 3. This is going to be multiplied by 5 times 3. And this is going to be multiplied by 5 times 3. Okay, let's do this. So that we have 5 times 3 times 1 over 5 plus 5 times 3 times x divided by 5 times 3 times x minus 5 times 3 divided by 1 over 3. So what this does is the 5 and the 5 to make 1, and the 3 and 3 divide to make 1. They cancel. So what are you left with? You're left with 3 times 1 is 3, plus 5 times 3 times x is 15x, divided by 5 times 3 times x is 15x, and 5 times 1, you minus 5. And that is one way to go about it. So this is our answer, but as always, we try to factor if we can a bit further. In this case, in our numerator, we can factor out a 3. If I factor out a 3, I'm left with 1 plus 3x. In our denominator, we can factor out a 3 as a 5. So we're left with 3x minus 1. We see we can factor a negative so that we can get the same thing in the parentheses. So I have, no, we can't because then they're both positive. So they'll be both negative. So it looks like we could, but we can't. So this is our answer. Now, which method do I prefer? The greatest common denominator, or using our knowledge and our previous learned skills? I like this way more. Because no matter how ugly a problem is, using our previous knowledge with order operations, we can always work it out. There's one other way you can go about it. If you'd like to learn it, go ahead and reach out to your e-text for section 5.4. You can find that on my math lab. All right, that's it for section 5.4. Thank you.